Thank you very much. And once again, it's a real pleasure to be here. And it's also wonderful to see such a full room this morning. I am very tired. So I'm not going to do this presentation in Portuguese. I've also been told that I need to stand very still right in this spot so that I can be on the live stream. And if you don't like my presentation, you can go on aiforgood.org and watch me on live stream instead, okay? And it's delayed by about a minute, so you can get the best of both worlds, right? Okay, so I was thinking about what to present when I would come here. And there's a theme that I've been getting a lot of questions about over the last year. And that's really what's going to happen to the economy as this impending rise of artificial intelligence robots storms into the workplace, rips people from their desks, throws them out of the window, and sits down and takes over the work that they've been doing so nicely in their accounting and legal profession and in factory floors and so on. And I get asked the same questions over and over again. It's both by my barber when he's cutting my hair, who asks when he gets to retire. And I also get asked this at United Nations meetings. I get asked it by top executives at Google. It's a question that I think is on everybody's minds, right? In fact, next September, I've been invited to give a keynote at a conference in Hawaii, which I obviously accepted before I knew the name of the conference. It's on emotional intelligence. And the conference is being run by a company that develops internal survey HR software to keep track of how employees are enjoying their position, to help them to develop further in their career. And what they started to notice was that on the surveys that they run on a monthly, quarterly, yearly basis, people are asking or talking about how soon their jobs are going to be changing because of the nature of technology. So at first I thought this was an abstract concept, right? That it's being talked about in the media, it's being talked about online. There are some chatbots that are being deployed to websites that say racist remarks, and we've been able to do that, not make racist remarks. We've been doing that for thousands of years, but deploying chatbots to make racist remarks, we've been able to do since the 70s. It's actually one of the really strong areas of AI. But I didn't realize that people in the office, people in their employment, were beginning to actually have conversations and worry about their jobs. And we're not talking about people driving for Uber having these concerns. Actually, most of the Uber drivers that I talk to can't wait to stop driving. They don't find it particularly interesting to drive around. Sure, it's a job that brings them money, but I don't think that they feel particularly fulfilled from navigating the streets of São Paulo. Maybe they would feel more fulfilled in a different city that had better street layout, but this is a separate question. But the point is, people are starting to have these conversations, so it's important that we begin to address it, and it's important that we don't blow these concerns out of all proportion also, right? Yes, artificial intelligence is now having a boom in terms of industry. Yes, there are things that we're able to do today that 10 years ago we couldn't do. A lot of that is due to the data that we've been collecting, the computational power that is becoming accessible. A lot of it is not to do with increases in the sophistication of the types of algorithms that we're using. Of course, we do have now a big marketing pitch around deep learning, right? And we love to think about using deep learning for all of our problems. The reality is that in industry, most problems today use very simple machine learning methods. If they use statistical machine learning methods at all, many industry problems are still solved through rule-based decision tree style of approaches. Now, what does that actually mean on a practical note? Well, it means that the technologies that we're seeing today, the transformation we're seeing today in industry, it's the beginning, right? We can do a lot, and we still have to do a lot to bring the industries of today up to the point where we can start to implement more sophisticated technologies. What I want to talk about today is how this automation, but also just how the job market in particular, the labor markets, the economic dynamics of change within these affect employment. And I'm going to do it through a couple of lenses. So one, I want to have a conversation with you all about the research agenda that I've been working on for a few years now, which is around employment structure. So looking within firms, looking within industries, looking at countries. And on the other side, I want to look at a particular case study, and I think that the case study will resonate quite nicely with everybody in the room because it's from the finance industry, and I'm going to look at the collapse of Lehman Brothers in 2008. And it's really an experiment in understanding what happens when people get laid off who were not expecting it, but people who are highly skilled and have transferable skills, right? People who work in finance tend to have skills that are not limited to just working in finance. They tend to have highly technical skills, problem-solving skills. They tend to be able to communicate effectively. They tend to have the ability to move into positions in many other places. They choose finance because obviously finance tends to pay better. Finance maybe has better kind of quality of work environment and other things. But in general, right, most of you in this room work in the finance industry in one way or another. You have transferable skills, right? You're highly educated, you have transferable skills. And a lot of the questions that I get are not about jobs that are menial task style of jobs. They're about jobs that are on a more highly educated intellectual level. Okay, so if you want to see this presentation, I gave this as a keynote at the KDD conference in London a couple of months ago. It's nice, it's got some pretty pictures and some emotive comments, but I'm not going to be giving this presentation today. What I'm going to do instead is switch to something that looks a lot more boring. And I'm going to, where do I? Look, see? Looks much more serious. Here we go, okay. Now you can see that I have some real research background as well, right? I can write LaTeX code to generate these slides. And this is a paper that's joint with Anastasia Fedek at UC Berkeley's Business School. It's something we've been working on for a couple of years. So before this, she was at Harvard Business School, and we worked a lot together on several projects, which you can find on our research page. So what I want to talk about with respect to this particular paper is the impact that the Lehman Brothers collapse had 8 years on, so up until 2016. I think we'll update it to be 10 years on soon enough, right, because we've been just waiting for the data to grow enough. But I'm going to also spend quite a bit of time showing you the data set that I have available and convincing you that through this data, we can actually get a good grasp on the processes at play when we talk about labor market dynamics, and that these data sets that we're using can be used to answer questions about automation in the workplace, about the role of AI in different industries, and not just from a US-centric perspective, which is clearly what I'm going to be doing from the Lehman Brothers angle, but from a global perspective. And I think that there are nuances in the global perspective that are different from what will happen in the US, which actually, what I mean by that is there are perhaps economies that are even more resilient than the US economy. There are obviously economies that are less resilient than the US economy from a structure of employment perspective. Okay, so we can get started. Right? The core question that we're talking about is, or what we were interested in when we were attacking this question, when a firm gets hit by a large exogenous shock that forces them to downsize, sometimes drastically and completely, how does that affect the future ability of those employees to get employed, to find gainful employment? How long does it take them Do they end up having to switch industry? Do they start more businesses as a result? How does it affect the real economy having these crises within a firm? In particular, if it's a shock that has nothing to do with the actions of most employees, and you're going to have to agree with my assumption that in Lehman Brothers, most of the employees of Lehman Brothers were actually just like the employees of Goldman Sachs, Morgan Stanley, Bank of America, UBS, right, Deutsche Bank, and so on. They did not play an active role in causing the collapse of Lehman Brothers, okay? We can argue that there may have been some people within Lehman Brothers that made Lehman Brothers structurally or significantly different from Goldman Sachs, but the prevailing agreement is that if it had not been Lehman Brothers, it would have been any of the other banks on a different day being denied access to the overnight lending. Okay, so we know we're looking at Lehman Brothers, and the nice thing that we're able to do as opposed to previous studies is look at actual individuals that were working for Lehman Brothers or across industry, rather than having to aggregate up at a firm, industry, country level, which is what you often see with these types of studies. Okay. And as I said, you guys are really smart, so highly mobile labor force, and also let's say that the finance industry tends to pay more than other industries, so people who get put out of employment may have enough cash reserves that they choose to take on higher risk endeavors, like starting a company. Okay, so just for some background, if you don't remember the Lehman Brothers collapse, it was really fun and exciting, and lots of news outlets wrote about it at the time, and lots of news outlets kept following up, tracking the progress of employees at Lehman and kind of the bankruptcy process of Lehman, fire sale of assets, employees moving to Nomura Holdings and Barclays Capital. In fact, Francisco was telling me a very interesting story last night where he had an offer to join Lehman Brothers right out of his PhD at Chicago, and he got a voicemail message early in the morning one day saying, "We're sorry, we've gone bankrupt, so we don't have a job for you anymore," right? And then he called back 2 hours later, and there was just dead phone lines, right? So at least they were courteous enough to call. I don't think Goldman Sachs would have called him, actually, just putting that out there as a... Bradesco obviously would have called, but Bradesco also would not have gone bankrupt, right? So just to be clear. Okay, so we have different perspectives also coming from the media. Obviously, these different media outlets, as Marco will tell you, have different biases, so they tend to write about things differently. Huffington Post takes this kind of very left-wing approach of saying that the Lehman Brothers employees who are responsible for the financial crisis and should be carrying this burden on their shoulders throughout their entire existence, and ideally spend that existence in one of the levels of purgatory, that they've actually been cashing in from this recovery and leaving other people behind. There's a causal kind of relationship that's being implied there. I'm not sure why Lehman Brothers employees having jobs would cause other people not to have jobs, but anyway. And then the Financial Times, this is 2016, right? So this is already 8 years on, is talking about anecdotal evidence that a lot of these employees actually went on to start very successful businesses. And this actually begs the question, so we're in an innovation center, right? And we tend to be of the opinion that innovation in markets, right, disruption in markets, causes new products, new markets to emerge, and in general that this will add jobs to the economy. Is this really true, right? Right? Who is creating jobs in the economy? So we talk about 4 million car or truck and logistics drivers going out of work because of self-driving cars, which is based on the assumption that they all get fired tomorrow and that it takes 0 time to implement self-driving vehicles and that all of the infrastructure doesn't require anybody to be doing any work within it. But okay, 4 million jobs disappear. So does that mean that we actually on net lose 4 million jobs from the economy and that's it? Where do these people actually go? What do they end up doing? What's the absorption rate, the background absorption rate of the economy? It turns out that if you look at least at the data sets that we have, and we've done a lot of studies on this already, there is currently no effect, no discernible, statistically significant effect from the introduction of the technologies that are automation related in the last 15, 20 years on the ability of the US economy at least, but this seems to hold true across other countries as well, to keep up with that disruption and actually on net generate more jobs each month than are lost. Right? So when somebody writes a news article saying that it's going to be an impending crisis because of AI technologies, it's based on zero evidence. Right? There has never been a time in history where we have had data showing that this would be the case. People argue that this time it's different. People argue that we've gone from agriculture to manufacturing to services, and now it's a cliff that we're going to fall off, and it's very different from previous times. But if you look at the data and you run studies actually looking and comparing different populations that are subject to an automation shock versus not, there's not much difference between their abilities to find jobs kind of 2, 3, 5 years out. And there's also not much difference in terms of the economy's resilience overall over time. Did you want to say something? And by the way, if you have questions, if you want to shout something out at me, if you don't believe something I'm saying, please challenge me during the presentation, okay? I don't want to hold you back, and I like this interactive style of discussion. Okay, so lots of people are interested, at least, right, which is good for me because it means that it's more likely that I can get the paper published. So what do we actually find? So I don't keep you on a cliffhanger for the next 40 minutes. So we find that people who were fired by Lehman or during the Lehman bankruptcy were working at Lehman Brothers were far more likely to take extended breaks from employment over the next 8 years. Makes sense, right? People are reevaluating after this shock. They're also more likely to move industries than their peers in similar firms, right? So this is people now not just reevaluating what they want to do, but also considering things outside of the financial industry. People also, if they did stay within the finance industry, tended to not be affected, or actually not tended to, they were not, on average, affected in terms of their career advancement. So 8 years on, the distribution of positions and experience held by Lehman Brothers employees still in finance was the same. It was indistinguishable from the career advancement of other people at similar firms, okay? And I'll show you what I mean by other people at similar firms because we've done quite a detailed analysis in order to be able to match these people in a way that makes sense and in a way that's convincing. Also, critically, the entrepreneurship channel seems to be very active. So people do choose to start their own firms. And here we're talking specifically about venture-backed firms, but also new starts in general, right? So that includes, obviously, managing directors that get laid off and then say, okay, I'm going to start my own fund, right? And maybe that's not so different from what a portfolio manager was doing within Lehman Brothers anyway, but still it's a different business. Maybe it has different economies of scale. It's hiring more people, fewer people, right? There's going to be some difference. Okay, so overview of this talk from a practical perspective. I'm going to talk about the data set. In fact, I'm going to try to spend, because we care about AI, machine learning, data science, and all of these things, I'm going to spend a little bit more time on the data than I would if I were presenting to an economics audience or a finance audience, academic audience. I'm going to show you some of the methodologies that we use in terms of reconstructing firm hierarchies, in terms of understanding career progression, about matching employees across so that we can say, actually, this employee looks like this other employee and track them over time and see comparatively how they do, right? And then we're going to show you some empirical results which hark back to the preview that I just showed you, right? But I'm going to show you statistically that there is a real difference between the people who were at Lehman and not at Lehman, but similar at that time in their careers going forward. And why am I showing you this case study about Lehman Brothers when we're talking about AI? And I said that it's going to be, the future of jobs in the age of big data. Well, I think it's important to give you an idea of the types of economic studies that are necessary in order to draw inference about what may or may not happen in employment markets over the next 10, 20 years. And I want to draw particular attention to the fact that I'm blending machine learning methodologies, which are based on the data sets that we have access to and representation of that data and the modeling of that data, with what are traditional econometric approaches in terms of getting at the causal channels, being able to instrument these data sets in such a way that we can see why something might lead to another thing and try to build a narrative on top of it that can then be used for policymaking or at least for a better understanding of the economy. That's why I'm showing you Lehman Brothers. Also, it was more convenient than writing a whole new paper just for this seminar. Okay, so as an aside, we use data from Cognism. Cognism is a sales and CRM platform. What they do is they collect data. They buy data from human resources companies, consulting companies. They buy data from recruiting firms like big resume dumps. They scrape data from various web assets. They buy data from places like Crunchbase and S&P Global for executive data. They are a huge repository of individual career data over the last 30 years. They have about 1.4 billion job change events globally. And that's actually, when you get down to it, right, so there are about, this number is well outdated because they've since purchased many more. It's actually closer to about 500 million individual profiles globally, and about 400 million of those are active and verified, and we have information about people's career progression through time. And career progression, well, I'll show you in a moment what that means too. In this particular paper, we restrict it down to just US public firm employees, which ends up being about 40 million people, represents about 40 to 60%, depending upon how you count, of US public company employees over the last 15 years. So it's a very detailed and also dense sample of the employees of US public firms over an extended period of time. We specifically look from 2000 onwards, but theoretically we could look from about 1990 onwards. It's just, obviously for Lehman Brothers, going much before 2008 doesn't make much sense. Okay, so here is a nice profile that I've picked out and where I've changed most of the details, so it's not actually a real person. And I've changed the places, and I've changed the dates and things like this. I'm sure if you tried hard enough, you could probably reverse engineer and find this person, but that's up to you. If you have a lot of time and you don't have a real job, you could do that. This is a JSON message that represents a reduced form version of what I get from Cognism, right? And I get roughly 500 million of these. So as you can see, I don't have a pointer, but everything is quite noisy, right? So the names of companies, the job titles, or the names of the education, everything is ad hoc. It's filled in by the individual, just like you would fill it in on LinkedIn, as you would put on your resume. And people make different choices about how they explain the positions that they've held in the past. We're also acutely aware of the fact that this is retrospective data, right? I build a resume today according to how I remember the past. And that can be problematic because I may remember that in the past, rather than leading some research groups at Bloomberg, I was actually the CEO, right? And if I happen to remember that I was the CEO at Bloomberg, then it's going to mess with the data that we receive. So what's clear from this is that we have to do quite a bit of data cleaning and before we can even get started on more machine learning oriented approaches. But the nice thing is, of course, that as Esteban was pointing out, we can use knowledge-driven statistical NLP techniques in order to clean up the data, in order to disambiguate these names, in order to understand better what's actually going on, right? And one of the keys that I'm going to show you throughout this talk is that the only reason we're able to use these data sets in order to gain economic insights is because we've spent 2 years cleaning the data and getting it to the point where it's useful. And what I would point out is that in most of the projects, and especially in finance, right, especially in an area where there is a lot of textual data, there's a lot of sensor data, there's a lot of raw information that comes in from various vendors and formats, most of our time as machine learning researchers is spent curating data, right? I don't care that there are like cool new embedding approaches in neural networks. Most of your time is spent curating and cleaning data. And it sucks, but that's the only way that we get good results in the end. Okay, so for company names, for instance, which is an interesting problem, and it's actually a problem that it turns out most financial institutions face when they buy outside data sets, right? It's matching the company names and company identifiers in that data set to the internal databases that you have. It's identifying when an equity issue, right, company name is the same or different from the entity that issued the debt, right, which when we think of IBM debt and IBM, Class A shares, depending on the market in which they're traded, they're actually issued by a different legal entity. So when we talk about IBM, we're actually talking about hundreds of different legal entities globally, each of which may or may not be publicly traded somewhere, or either as an agglomeration or independently, each of which might be owned partially by other firms, each of which might have completely different names from each other, and therefore it's a mess, right? Actually, linking things properly, having a good concept of what a company is really difficult. It's easy if you're only trading equities, right, in the US. Then there's a nice list that you can get from the 3 dominant exchanges. If you start going to the OTC market, like the pink sheets, then it gets more complicated. But what we're able to do through a variety of disambiguation approaches, through a variety of knowledge-based approaches, statistical NLP in terms of stemming the names, understanding when there are legal identifiers, using alternative data sets like open corporates and other places where they've done some of the work of linking legal entities, we're able to link entities from the Cognizant data set on an individual basis to real public entities in about for about 89% of the US publicly traded firms. It actually turns out that we do it for 100% of the firms that we're interested in, because the firms that we're interested in are firms that have employees. Now, US public markets have this interesting feature where it's possible to have exchange-traded funds, right? And they also count as identifiers on these big exchanges, but they have 0 employees. So it turns out when you remove those, we actually cover all of the employer firms in the US that we're interested in. We have fairly good precision, so we're getting, maybe roughly 9 out of 10 cases where we have a name that can be disambiguated to a public firm in the US, we are able to do that. Okay, so that's fairly good. We're also linking this across, and this is important, to financial data sets for pricing information, for company debt structure information, for understanding ownership, right? So this is actually getting it across into the CompuStat and CRISP databases, which come from the Wharton Research Data Services databases. And it's an unbalanced panel. That means that we have fewer firms going back in 2000 than we have today, right? Today, we cover pretty much the entire market, but if you look at our performance in 2000, we have fewer firms. So we do have this survivorship bias that's built in. This is problematic if I were to build a trading strategy on this. It's less problematic from the point of view of the firms that we're going to be analyzing in this paper. The reason is that all of those firms survived the entire period, so they're comparable. Okay, and then after we've spent a really long time building machine learning techniques and validating what we've done, we end up with the cleaned up version of that original profile, right? So we have, for example, you'll see here we have gender and ethnicity classification, which in the US, Hispanic is covering, 90% of the world outside of the US. So this is actually, I didn't actually decide on the classes that go into this. We can agree or disagree about it, but in any case, location-wise, we actually use the GIS coordinates for cities and regions, places. So we know if the greater Boston area includes Quincy, right, or Cambridge and other places, as opposed to just having a name. That means that we can ask for all employees within New England, for instance, right, those states that are in the northeastern US. We also infer a date of birth. Now, how do we infer a date of birth? Well, we do it through the education record, right? So we make assumptions about when people start their education. We make assumptions about when people start their first job. Often people do have high school listed in there. High school is a much better marker than college even. College, people tend to start at 18, but there might be variants, plus or minus 2 or 3 years. In the cases where we don't have that, we tend to use closest approximation of similar profiles that were not missing that critical information. So people in the same place, studying the same thing, that started their job at the same time with similar skills will infer that they're probably the same age as the profile of interest. I'm going to talk a bit more about skill sets as well a little bit later, because skill sets are maybe one of the biggest assets in this data set that cannot be had from elsewhere. And it's also one of the things that economists are most interested in when they're studying the labor markets, is kind of how transferable are skills, how mobile are people, how do skills develop over time. So this is an important aspect of this data set. Notice that we don't just care about companies, we also care about the education. And that means also having education institutions like universities be part of our taxonomy of organizations of interest. And what we're able to do on that front is take a variety of classifications of universities and also the rankings of universities, and we're able to compare people also by how elite a university that they attended might be, right? So, for instance, University of Chicago, PhD in economics, is more elite than unfortunately, University of São Paulo, economics PhD. Just to make that point. I'm sure Francisco would have mentioned that in his presentation as well, but and this is, we're trying to get at real attributes of this data that might make a difference between two people's career outcomes. So ultimately, the more color we can get, the more rich we can make it, the better it's going to be. Now, in terms of job titles, I'm also going to show you a little bit more about job titles, but job titles are the hardest problem that we've had to deal with. And bear in mind, I didn't mention this, but Cognism started in 2012. I am actually an investor in Cognism. I'm an angel investor in several companies. I'm an investor in Cognism. And actually, that's mainly the reason that I have access to this data, because one of the ways that I invest in companies is in exchange for data access where I think it might be useful for research topics that are societally relevant, that's my investment approach. But job titles, because people tend to infuse them with all kinds of additional information, with confusing information, right? For instance, saying things like CEO/founder, right? But a CEO/founder is not really a job title. It's more it's two job titles, one of which is not a job title. It's more of a description of when the person got involved. And even CEO of a startup is really like a sole business owner, like a sole proprietor. It's not really a CEO, right? It doesn't have the same operational consequences as CEO of Cisco or Microsoft. So there are nuances in terms of individual roles at particular companies, the way that people talk about those roles. We also, from a natural language processing perspective, found all kinds of additional problems that we needed to solve. For instance, it turns out, and I'm not going to spend more than about 30 seconds on this, but it turns out that the slash, when people write their job titles, so this forward slash in between job titles or in the middle of this phrase, is really tricky. So there are multiple interpretations of a slash. And this is probably not the most interesting topic in the world, I'll agree, okay, but slashes are really important from a semantic perspective in job titles. It turns out that the slash has dependency rules. So I can say that I am, chief economist slash programmer, right? And that can be interpreted in a few different ways. It could be interpreted that I'm the chief economist and I'm a programmer, right? Separate duties. It can be interpreted that I'm the chief economist and the chief programmer, right? Also, this is kind of, it's easier with something like maybe two things on the same level, like assistant editor slash developer, something like this. On the other side, you can have something like the other way round, which would be where you're, let me think of a good example of this. Yeah, so business slash development analyst, right? Are you a business and a development analyst? Are you a business analyst and a development analyst, right? So you see, the slash has this kind of strange way of messing with your mind, and it's not a problem that you would ever actually think of solving for the traditional NLP tasks, right? I'm pretty sure, Estevam, that in NEL there is not a model for slashes, right? Resolution of dependencies of slashes. Okay. Turns out in job titles there are all these weird syntactic variations that you need to take account of. So we've got on the order of about 15 or 20 syntactic and semantically driven models in order to disambiguate job titles and in order to tie these job titles into taxonomies at national and international levels. So in the US, job title taxonomies come in the form of the ONET classification from the Bureau of Labor and Statistics. In the EU, it's ESCO, the European taxonomy of job titles. And there are also some international taxonomies of job titles that have been more recently created. There is one in France that's specific to French language job titles. So really you have high variance across these. They tend to be either broader or narrower depending upon who made them and what their purpose was, right? Often it's for calculating national statistics of labor market participation. And so we disambiguate also into these taxonomies, which allows us to compare across industry according to national guidelines. But we're also interested in understanding how a particular company evolves over time, right? So we have to normalize within company. Once you normalize within company, then you realize that it's harder to compare across companies, because it turns out that if you are an analyst at Goldman Sachs, first-year analyst, you then, after a couple of years, will be promoted to be an associate. However, at other banks, you start as an associate, and after a couple of years, you're promoted to be an analyst. So that confuses everything, just this choice of words. A vice president in a bank is nobody compared to a vice president in a pharmaceutical firm, right? They're completely different levels of the hierarchy. A vice president in a bank is somebody who's been promoted from analyst or associate, whatever the second level was. A vice president in a pharmaceutical firm is somebody who is in one of the top layers of management of the firm. So you cannot compare these on a lexical level. You have to compare them on a semantic hierarchical level. Okay, anyway, I've spent far too long on that particular slide, and we'll go back to the skills soon. I wanted to ask a quick question. This is just to wake everybody up because I've bored everybody to tears. So, now that we've got these data sets disambiguated, right? Now that we understand how people move from one company that we understand to another company, where is it, right? Now we can start to view what industry shifts look like, what the economic shifts look like in the labor market, and I can focus in on one company. And Estevam has just left the room, so we can feel more open, right? Where do people, after Amazon, where do they go? Is it to hell, right? Where do they go? Anybody want to hazard a guess on this front? Bradesco? Yeah, I think, well, you ruined it, okay. Nobody wants to guess. Oh, usually people want to guess. Okay, I'm not going to talk anymore until somebody guesses. eBay. That's a lame guess. Okay, I want a good guess.
Someone said Google.
Google? Okay, all right. So originally I thought Amazon, right? Okay, it's retail trade. So maybe Walmart, maybe eBay. Well, basically a company that has similar genotype, right, in terms of the products, the type of business that they're running. Maybe logistics operation, something like this. Well, it turns out that Amazon is in Seattle, right? So most of the employees of Amazon are in Seattle. Well, okay, but the largest density of Amazon employees is in Seattle. Let's use correct terminology. So Microsoft is also in Seattle, right? And Amazon is actually a very tech-heavy firm, right? AWS, also all of the infrastructure of Amazon is really built in a tech-centered fashion. It's not built as a traditional logistics firm. So the nice thing is that, I was mentioned earlier, you have really high labor mobility, right? So if you work at Amazon as a highly paid tech entrepreneur, tech guy, don't worry, you can still go to Starbucks later, right? So you don't lose the ability to make good coffee just because you worked at Amazon, which I think is, yeah, anyway, that's quite nice. You missed it. You walked out at just the right moment. Anyway, so Esteban, when he finishes at Amazon, will likely go to one of these places, I would guess. Right. Right. Well, we know you'll go to Starbucks, but it's a question of how long, right? Okay. So the next thing that we can do is aggregate up. So from the firm level to the industry level, right? I'm just showing you these pictures to show that we have good coverage of industries and that we can get some novel insights. So this is a radiograph, right? Basically what it's showing is when the arrows are touching, right, and moving out, these are people leaving that industry. And then when they don't touch, these are people who are coming in from that industry, and the colors represent the industry where they come from. So biggest one is manufacturing down at the bottom. We've got finance, we've got information industry, which is one that clearly has been growing over the last 20, 30 years. Retail trade, Amazon fits into here, as we just mentioned. Government jobs, public administration. This overlaps also quite a bit with healthcare, it turns out. Yeah, health and social assistance. So it turns out a lot of the healthcare agglomerations in the US are classified under government and public administration. Professional, scientific, and technical, this would include pharma firms and things like that. So actually it turns out that, and this is aggregated movement of employees, so it's only covering the movement of employees, right? The size of the segment represents the number of people shifting, not the number of people in the industry as a whole, only the people who actually actively moved within that period, from 2000 to 2016. And it's just to show you that we have good coverage across most of the high-level NAICS, North American Industry Classification Code system. It's not a ratio, no. We have other graphs that are the ratio, but yeah. Mm-hmm.
So does it actually mean labor, like manual labor?
Yeah, so this is a really good point, right? Because the NAICS classification system was built for a very different time from how we use it today. NAICS was built when most people had careers that spanned 40 years. They had pensions paid for by their employer, and employers had hundreds of thousands of employees. Right? The number of firms with hundreds of thousands of employees in the US is maybe 3 or 4 now, as opposed to 20, 30 before. Right? The number of employees needed in big manufacturing firms like the American steel firms and aluminum factories, aluminium factories, depending upon where you are, has drastically decreased. those people now work in different sectors, new sectors have emerged. And so one of the points of the research that I do in this area is actually to come up with new classifications of industry that are more aligned with the skill sets of the population and how labor actually moves through this economic environment rather than this classical assumption that people stay fixed for a long period of time. So you're right that in some sense this is not a good diagram of people shifting skills, but it's a good diagram of how people who, and the industry classification system is used everywhere, right? It's used by BLS in order to keep track on how the economy is growing or shrinking and which segments to subsidize more or less. So whether we like it or not, it still has a big impact on policymaking. And this aligns very nicely with the BLS data on industry moves over the last 20 years. So it shows that we have good correlation with BLS data, which is the only point I'm really trying to make, other than the point that I know how to make really pretty charts in R. And if anybody wants the source code for making this chart, I can provide that openly. Maybe that's the most interesting and relevant part of my talk. All right. So everything I've spoken about so far, other than aggregating at a firm and industry level, is fairly flat, right? It's about individuals. Every individual is assumed to be roughly the same. It's a bag of individuals for each firm and a bag of firms for each industry. Now, I was having a conversation yesterday about the fact that really the labor market is a time-varying graph. People move from one firm to another. People develop during this time. People have different types of relationships with the firms and with each other within this graph, right? If I went to school with Esteban, which I didn't because I'm much older than he is, but if we went to school together, then we would have potentially an implicit link in this graph. If we worked at the same company at some point, we would have an implicit link in this graph. So there are many relationships that you might want to represent. And you also care about career paths. You care about hierarchical relationships within people's career progression. And in order to do that, you want to be able to actually understand what these hierarchical relationships are and how they're changing over time. So the aim, in some sense, is to go from a big dump of resumes across everybody to an understanding in a particular month in time what the hierarchical organizational chart of one firm actually is. Okay? It's a fairly hard problem. Okay, so we make one simplifying assumption, which I'm not sure if it's listed here. This is a graph construction technique, but the one simplifying assumption that we have to make, which is debatable, and again, well, you guys didn't really give me an answer to where do people go to Amazon next, so I don't expect any questions on this. I feel quite secure. But one big assumption we have to make is that when we leave one job, the next job is at the same level or higher. Okay? So we make an assumption that as people shift in their career, they tend to move up hierarchically within a firm. So as you go through time, you're also going up in the hierarchy. If we don't make that assumption, then we can have nothing but a bag of titles, right? There has to be an assumption that people develop and evolve in their careers upwards in order for us to build hierarchy into the system. So we're making also some statistical assumptions about the distribution of jobs within a firm, which are structural distributional assumptions in order for us to end up with a hierarchy rather than a graph that goes all over the place and loops back on itself and ends up being difficult to work with from an economic analysis perspective. So what do we do? It's actually better to think about it graphically. So we have several pruning mechanisms in order to keep the graph manageable at each step. It's an iterative graph building process. We seed the graph with the first job that people have after their undergraduate degree. And if they don't have an undergraduate degree, then with the first job they have after high school. And if they don't list high school, they're not part of this process of seeding the graph. So education to the first job, and then we observe that there are jobs that occur after the first job, right? So we have a big list of these jobs that occur afterwards, job B, job C. Now, we also have to make a structural assumption that there is some relationship between an earlier job and a later job, right? And in order to simplify, then what we assume is that job A only leads to a job N if that job started after job A finished. And that's to avoid a couple of things. One, it's to avoid the fact that a job needed the same set of skills in order to begin. So if I start two jobs, right, two part-time jobs, then maybe they're both dependent on my previous job rather than one being dependent on the other in terms of what I've learned. And I'm trying to build structure, so I care about what people are doing in terms of learning and evolving in their career. And the second one is that we also are trying to avoid part-time employment or charitable volunteer employment and this type of thing. So we have checks in place that try to prune out these jobs that are not full-time jobs. So we're only going to link job A to job C in this scenario. But job D, which occurs both after job B and job C, is going to receive a link in on both of those. And then we repeat this process over and over. And as we get through the entire data set, we then go through the graph and we prune based on a variety of graph theoretic measures of kind of the number of links that are appropriate from any one stage. Also, the structural assumptions that we've made, structural distributional assumptions that come from the statistical assumptions. And we end up with this big graph by firm, by month, which shows you the rough hierarchical relationships that exist between the employees that were active on that date. Okay, so I picked out one that I thought would be highly relevant to this crowd, right? And this is actually Luca and Vanessa. I think we were both sitting on a beach when I was generating this chart a couple of years ago, right? So this was in the middle of the graph building process. I was having log output, and I had a presentation I needed to do a week later, so I just kind of stopped the log output for a moment and chose a random one. There are 142 instances because I stopped it fairly early on because I'm not very patient. But there are actually tens of thousands of senior pastors in the data set. But this is fairly representative of what the end result was for this job as well. So people tend to stay in this job for 10 years. They tend to be 38 years old, kind of on average within this job. 100% male. That's not really surprising, right? It's a religious occupation, so it's and it's pastor. So in general, these have been 100% male, but it's a good check, right? We haven't accidentally put too many women into the pastor role. I'm not saying that we shouldn't. Please don't get me wrong. I'm just saying that we've done a good job with the data. The most frequent education is in a seminary. This is just the top. Most frequent. It's not that pastors didn't also go to, I don't know, Columbia or Carnegie Mellon or somewhere like this. And the most frequent previous role is that of a pastor, which kind of makes sense, right? I don't really understand the hierarchy of the church or of the, I guess, Presbyterian church, but pastor to senior pastor seems like a reasonable transition. Okay. But going back to Lehman Brothers, right, since this is what we care about, I'm just wondering how much time I have. I'm good. Okay, good. So thinking about Lehman Brothers again, we need concrete instances, right? We don't care about pastors in Lehman Brothers so much. So this is the role frequency of people that were matched to Lehman Brothers working in 2008 before the bankruptcy. And you see, okay, they have a lot of analysts, they've got a lot of vice presidents, associates. And as you have fewer and fewer, it tends to be that the position is higher up in the firm. Tends to be, right? I'm not sure that associate should be fewer people than vice president, but what somebody pointed out to me is that a lot of associates end up leaving, right, after just 1 year in order to pursue MBAs. So in the firm, you tend to have fewer years of associates than you do of analysts. Analysts will always be there for 2 or 3 years. The associates might only be there for 6 months, 1 year. They're just waiting to become associates in order to get into the MBA programs. So this might be one reason why it's that way. Anyway, this is just frequency, right? You'll also see things like this, right? This is an assistant vice president or an associate vice president, depending on the firm that you're in. And AVP is just above, and below this number in the list, there is associate vice president also. So there's a lot of disambiguation that needs to be done. This is the raw data. Now, flip this over and look at the least common job titles within Lehman Brothers. The one that really cracked me up, right? You know, senior summer analyst. Who the hell are you managing as like a summer analyst? You know, somebody, I don't know. You know, cocaine is fairly prevalent in the financial industry, so it could be. But you also get the idea. So this is not a job title, right? Derivative settlements is not a job title. It's an area in which somebody was working. It's maybe it's a desk that they were working at. A trading winter analyst, you know, also interesting. So it has more information than just a raw hierarchical indicator. And as a result, yeah, so the idea is that we do want to have all of these jobs, even the ones that appear just once or twice, because most of the time it is people genuinely wanting to share their career. But if we keep all of them and we're not doing a good job at disambiguating, we end up with a really weird looking graph. And I've got such a graph for IBM, but it's not in these slides. And when I zoom out from it, it's basically just a big hairy ball of IBM employees. Again, I'm not saying IBM employees are especially hairy. I'm just saying it looks like a hairy ball. I'm just clarifying. Maybe they are. I don't know. Okay, so we have some rules that we also put in addition to the statistical models that I mentioned earlier. But because this is an older slide deck, I haven't included some of the models on slashes and ampersands and dashes and commas and linguistic kind of syntactic relationships that exist within the job title. We do all of that stuff. This is also a fairly interesting case, by the way, because if you use the naive rules that are often in the literature that does exist. So for instance, there are some papers using LinkedIn data where they don't take this into consideration. It turns out there are more jobs that are something to the CEO than there are CEOs. So if you don't take into account this, you've doubled or tripled the number of CEOs in your data set, which can cause a lot of problems. Okay, and yeah, so we're basically using machine learning to do this. We're not using deep learning. These are sequence taggers that we're mostly using. They either fall into the latent graphical model space, like a conditional random fields approach, or they're Markovian, so an HMM style of approach. And on top of that, we have lots of kind of binary classification models that we build into this in order to vectorize the input in a nicer way. So adding different features of the linguistic data so that we can work with it more easily. Now, I wanted to show this because I think it's important to also think about frameworks, how we're actually tagging these data sets. And clearly, we've got 500 million different job title instances, right, that fall into maybe 100 million distinct job titles that we have, 1.4 billion job title instances that fall into about 100 million plus job titles. So we couldn't tag all of them. If we could, then we wouldn't need to do any machine learning. But instead, I've found this, in fact, it's something that we used at Bloomberg as well for doing internal tagging of data sets. It's called BRAT, which stands for the BRAT Rapid Annotation Framework. So it's like the PHP, right? It's a recursively defined name. And BRAT allows you to very easily create these annotation tasks, which just allow people to select the span and choose the tag that you want to associate with that span. And you can do complex hierarchical relationships. You can build in lookups, right, like for Google and Wikipedia, so that the taggers can find information more easily. And also the taggers can leave you notes explaining the decision that they made for each of these. And so we created an annotation schema for job titles. And that includes things like identifying the department, the function, the role type, the position that people are in. And I could explain what each of these terms mean. We've got very technical definitions of when something counts as a position and when it doesn't. But the idea is, if the title actually explains what you were doing on that job, right? So if it says mechanic, right, that's a role. That's actually something that describes what you did. If it says that you were a representative, it doesn't really tell me what you were doing when you got into work in the morning. Did you come into work and represent things? Probably not, right? If it says you're an analyst, I mean, you know, the ironic thing about analysts is they seldom actually analyze anything, right? So, you know, a lot of things like this didn't really, we were being very careful to actually extract information in a reliable way from these job titles, and we tagged maybe 100,000 of them. So it was quite an extensive tagging, and this is what allowed us to build kind of the automated tagging infrastructure for the job titles that then really helped us disambiguate those titles. Okay, now one that's more reasonable and more relevant to this particular talk. So managing director, specifically from the finance industry, of which we have 3,700 in the panel of firms that we decided to work with. And average age about 44. They stay in that role for about 4 years. They do tend to change role between managing director and managing director several times. So each instance of the managing director role counts as one. So although they spend 4 years, they do tend to ship themselves about quite frequently in order to try to get higher salaries, you know, evolve in their job. It tends to be that if you start as a managing director, and probably you all know this, if you start as a managing director at Goldman Sachs, it's likely that if you want to progress to being a partner or a, you know, senior managing director or, you know, whatever the next role would be, that you want to move to a smaller firm. Because you might be waiting at Goldman for 15 years to progress, and you might be voted against to progress and just be stuck in an MD role forever. So if you do want to progress, you need to kind of move about, get outside options. So it tends to be quite short. Executive director was the most frequent role before then, but there are a variety depending on the firm, right, that kind of are similar in terms of the frequency. The funny thing is they're not highly educated, right? They don't have master's degree for the most part. It's just bachelor's degree education. And that maybe gives you an idea of the level of technicality that has been necessary in the financial industry historically. And you know, one of the interesting projects that we're working on now with some researchers from Kellogg and also from UC Berkeley is to understand whether there is currently a structural shift in terms of the skills necessary for these types of jobs as opposed to what was necessary in the past, right? And you might imagine that now there are more people with technical degrees, engineering degrees, appearing in these types of roles, or maybe we're still 5-10 years away from that happening as these people are coming up through the ranks. Okay, so you know, one of the later things before I show you the results of this, how do we actually match employees in order to do our economic analysis, right? Because ultimately I have a huge amount of data, but in order to do an experiment that I could convince you of having some causal roots, I do want to identify groups that are, you know, in one type that have been that have had the treatment effect, going bankrupt and being put out of a job, and B, people who are otherwise indistinguishable from these guys that were not subject to the treatment going bankrupt. And then I want to observe how these people evolve over time afterwards. So in order to do that, we're going to compare the Lehman employees at the point in time before the bankruptcy, right, to the closest employees based on a variety of features of the data. So gender, age, education, the skill sets that those people have, and a variety of other features that we put into this. You can think of this as a clustering problem, right? Which are the, in the high dimensional space, the people who are closest to my guy of interest at Lehman Brothers on that date. And we get the first closest, the 3 closest, the 5 closest, the 10 closest, and we run different specifications of our tests in order to show robustness to that particular choice of modeling. But we have an enormous number of skills as well. Because if you on your LinkedIn profile put that you know C and you know C++ and you know Java and you know Python and you don't put programming languages as your skill, they tend to be very low level. The most common skill that we see is actually Microsoft Word. Okay, not a very informative skill. It would be more informative if people wrote "don't know Microsoft Word," right? It would give you a better signal of that person's ability. So what we actually want is a taxonomy of skill sets. We want a smaller number that we can work with and that actually have some signal, some power in terms of telling us something interesting. So we're going to do this in a way that gets us a handful of skill sets on multiple layers of hierarchies. And from just me mentioning this, it should feel quite obvious to those of you who are more on the machine learning side that this would fall into a mixture modeling, graphical model style of approach, right? We have the latent variables, right? Some process happening underneath that is making people be skilled. And what we're able to observe on the surface, right, the observables, are these words that represent skills, atomic skills that people have in the world. And so we want to basically understand how that process, right, causes similarity among these skills, among the skills that we observe. And we want to reverse engineer that and then group skills together that were generated by a similar process. And so the natural setting for this is like an LDA or an LSI style, so latent semantic indexing. So basically, it's a matrix dimensionality reduction problem. So the latent Dirichlet allocation has a nice feature, which is that it chooses to use a Dirichlet prior, and that just gives you nice properties in terms of the size of the clusters that you end up with and how it kind of adheres more to the natural distribution that we observe. So it's an empirically chosen distributional assumption. And it's unsupervised in the sense that I don't have to choose a number of clusters, and there are obviously parameters, and if I modify those parameters, then it's unsupervised in the sense of what we call unsupervised in machine learning, but it's something that I've noticed people are quite skeptical about, because if you ask an economist if our model is unsupervised when it's doing clustering, they'll look at you like you're kind of a psychopath, because you've got this long list of parameters that you're deciding on, and then you're pretending that none of that ever happened, and you're saying it's unsupervised. Whereas if you change any of these parameters, you can have completely different answers coming out of the model. So it's unsupervised for us, right, in this room. It's not really unsupervised from other people looking in. And what comes out of this LDA style of approach is some clusters of these skills that are meaningful for our modeling task. So we have the IT cluster, right, and these are some of the skills that appear most frequently within that. The sales cluster, so programming, development, video, research. There are about 45 skill sets in total, organized hierarchically. And if you're interested in the paper, there is more information. And then just to give you an idea, right, so here's an employee, randomly chosen employee, has these atomic skills on the lowest level. So things like IT, software project management, infrastructure, leadership, right? One of those great skills that you can learn online, I think now in MOOCs, right? So we got two skill sets that we assign to this guy automatically. One is operations management, and the other is IT management and support. I mean, to me, these make intuitive sense based on the skills that I observe. Here's another one, different person, social media, non-profits, event management, public relations, right? Sounds a bit like the stuff that Maisa has had to do in order to organize this event. And here we are, social media and communications and recruiting. Okay, no, it's fair. Not really fair for you, but fair for this. Okay, so hopefully you get an idea, right, why that is important, because if you get these underlying skills aren't going to be very useful for comparing people and getting a broad idea of what's going on, right? There are 20,000 of these skills, more. Most of them are kind of meaningless unless you are able to group them together by types. Okay, so I've shown you all of this, right? So what are the actual empirical results of interest here? So I mentioned before, right, that people are more likely to switch industry. So once we've got these skills, I forgot to tell you the end, the punchline of the matching. So here are the other firms that we chose as the matched firms. So we've got Morgan Stanley, Goldman Sachs, UBS, Deutsche Bank, right? And these were, again, propensity matched. So they're matched based on features of the firm, as well as perception of what those firms do in the marketplace. And they all have extensive operations in the US, roughly similar number of employees working in New York area. So fairly comparable on that front. All on January 1st of 2008. We then look again at these employees, right? We take the snapshot of 2008 and we take the snapshot 2016, exactly 8 years later. And there are a couple of, structural assumptions that we make about representing the data. One of these is related to people who take time off. So time off is not really represented in a resume, it's implicit, right? It's between jobs. So we actually represent it explicitly within our data set, and we take anything that's at least half a year, right, of no employment, and we label that as time off. Half the profile length is just missing. So if we're missing half of the time that the profile has been active, right? So they say I went to high school in 1965, and then I'm a managing director at Bradesco Bank in 2010. Then we drop this person because we don't actually know what they were doing. We assume that they didn't just take time off from 1965 until 2010, right? They probably did something else because I don't think Bradesco hires people after 35 years of inactivity, but maybe. And then the other one is time off, which is a contiguous spell of 1 year or more with no reported employment, but not spanning so long that that the person clearly just didn't update their profile. And this is to be able to tell the difference between these two states of the world, missing data and actual time off. So the likelihood of actually taking time off, so this is Lehman Brothers here, and we're basically showing statistical significance of this, right? So you can see that Lehman Brothers is way off in terms of the number of the marginal, additional numbers of people that are showing time off of more than 1 year versus the grouping of Goldman Sachs, Morgan Stanley, Deutsche Bank, and UBS. Okay, that's interesting enough. But we have some hypotheses why they might take time off, right? Because they were all fired on the same day, and it takes time to adjust, and they might rethink what they're doing with their life. Okay, so we've done this looking at 1 closest person, 2 closest people, 5 closest people, right? So this is basically the same thing as I was showing you on the slide before. So we get a highly statistically significant difference between these groups. We also have an effect that we can, when we break it down by the seniority of the people, we find that actually the younger people, the less experienced people in the firm, are less likely to take time off, right? Whereas the people who have the financial means and can afford to take the time off, they're more likely to have taken time off. Okay, so analysts and associates who have actually, if you take New York and you look at analysts and associates, they don't make that much money compared to the people higher up in the firm. Actually, it's kind of like a cooling period when you join finance. The first 2 or 3 years, you're not expecting to make a huge amount. You're expecting bonuses once you actually become responsible for large enough funds and so on. So these people don't have savings, especially not in New York. So they tend to need a job fairly quickly. The other guys have more flexibility, right? If the heads of groups, even more flexibility. Okay, and then industry switches, right? So these are now we're looking at whether people were able to go from finance and use those skills, financial skills, in other places, and where did they go, right? So we look at whether they fell in the same industry, right? So you see just anecdotally, fewer of the Lehman employees stayed in the finance industry. Again, we look at the likelihood of switching over those 8 years, and we have highly statistically significant differences in terms of the matched employees. And again, based on seniority, people who were more senior, but not, the people who were more senior tended also to be better able to find other industries and transfer those skills. Again, people who were just starting out maybe got pigeonholed early on. That one is a bit harder to explain fully, because I would have expected that the younger people would have more energy and more likely to reassess things sooner. But anyway, this is maybe more, we can do more work on explaining that. Now, where do they actually go if they don't stay within the finance industry? So they tend to go to these professional, scientific, and technical services, so pharma industry, research companies of one type or another. Transportation and warehousing and manufacturing. Okay, that's not quite sure I get that one fully, but education, information, and real estate, these ones make maybe a little bit more sense, especially information, right? As people, as more companies fall into information anyway, as it's a growing area, so this makes sense. And here's just a chart showing you how this differs across the different industries. So a lot going to the professional, scientific, and technical, so more tech-heavy industries. Okay. So actually, given the fact that we're interested to see, right, whether people who were subject to this bankruptcy were less likely 8 years on to be making the same amount of money and have progressed in their career. Now, we can't observe compensation. We don't have compensation data here. We only have aggregated compensation on an industry level through Bureau of Labor and Statistics. But what we can do is we can observe whether the career paths differ significantly over that time, right? And this harkens back to also the idea of, as you have automation entering the economy and people are put out of jobs, let's say that they are, how long does it take the economy to reabsorb these people, and how far behind their peers do they end up based on the original choices that they made in terms of their employment? So we're going to compare Lehman Brothers employees with the others, right, as we did before. And what we find is that there is really no statistically significant or consistent difference one way or another across the panel, right? So there are some firms that seem to be associated with lower future career trajectories, like Morgan Stanley. So, you might not want to start your career at Morgan Stanley. But in general, Lehman Brothers employees were just as likely to progress in their career as anybody else in the finance industry. They were not punished, right, for being part of a company that went bankrupt. It's one of the main findings that we think is interesting. Now, the other finding, and because this is still, despite the fact that it's been worked on for 2 years, what you'll find in finance and economics research is that you can have working papers for 4 or 5 years, and they change, and sometimes they get split into multiple papers. So there's an entrepreneurship angle to this paper, which we might end up splitting into 2 papers. But that is that the people at Lehman Brothers were more likely to start their own company, right? And this falls into a slightly different literature in finance, or entrepreneurship literature, which is an emerging field. And so we're basically identifying the ones that are actually startup firms, right, more likely to be VC-backed. And what we're trying to identify is where the Lehman Brothers employees ended up actually starting those firms, right, founders, CEOs. And this is corroborated also with the company profiles from Crunchbase and AngelList, so we get more of the VC-backed firms. And you see that pretty much across all of the categories, Lehman Brothers employees were starting more companies, right? That Lehman Brothers entrepreneurship rate was higher than the background rate for these matched firms. And so I find that to be also quite an interesting thing, because although it doesn't tell us whether the entrepreneurial activity of the Lehman Brothers employees that were made bankrupt contributed positively to the overall growth of the economy, if we do believe in the fact that innovation is necessary and entrepreneurship is important to the health of the economy, then what this shows is that even with these exogenous shocks to firm, this disruption that comes from outside, which cannot be predicted necessarily, the economy is still able to get people to innovate and disrupt after that and recover without incurring any long-term effects from that crisis. And this is good. It makes only a point about the US economy. It doesn't necessarily say that Brazil or Canada or UK would react in the same way, right? Different policies and regulations can have different outcomes, but it does point positively to entrepreneurship as a channel for economic recovery and innovation. So just to quickly conclude and tell you what I already told you in case any of you were asleep. So we were looking at what happened to Lehman Brothers employees after Lehman Brothers went bankrupt, right? I want you to remember at least that much. Then there's no real difference in the career progression of Lehman Brothers employees in the years afterwards from their peer employees at other firms that did not go bankrupt. They are more likely to have taken breaks. They're more likely to have started new firms. And in spite of that, on average, their career progression is still, for those who remained in finance, equal to others. So it means that it's not that the worst employees remained in finance. Really, it does, I think, point to the fact that people in this industry are highly skilled. They have transferable, they have mobility in terms of their decisions. And really, it means that, when you go home tonight, you might want to think, should I start a company? Should I take a break? Should I, leave the finance industry? Because, to put my AI for Good Foundation hat on, we need more people to leave the finance industry, right? So that we can work on saving the world and things like food security. Okay, that was a bit of a joke, I guess. Anyway. Okay, and then I have a whole addendum for answering questions that people might ask that are hard to answer without slides. I'm going to stop there. Again, I think that there is an enormous amount that innovation and entrepreneurship can do in the economy. That's my personal feeling. It's my personal feeling also from being an investor in early stage companies. It's a feeling from having built early stage companies and observing founders and startups going through the motions. There is evidence that in the US at least, early stage companies account for most of the labor market growth in terms of number of jobs. And that growth is persistent after 5 years. This is also an important thing to take note of. That's separate work. It's not stuff that we've looked at specifically, but I think that it is important because when we consider the fact that there will be systemic shifts in labor markets over the next 50 years, and that's regardless of technology, it just happens because of consumption choice changes, but there will be systemic shifts. The point is to build an economy that is resilient and gives us the types of outcomes that we want long term. right? And promoting innovation, as this building is all about and this event is all about, is one channel by which that does really happen, right? Lehman Brothers is an interesting example because we're all in this industry, but it's just one example. It's just one case study. This is how I like to go about identifying whether the claims that we make in society about the future might hold some weight. And what I'm promoting is that we do more economic analysis of these situations rather than taking the predominant view of the media in terms of panicking about the future state of the world or what might happen because of AI, right? It's better to take a more reasoned, sensible approach and look at the data that we have available and try to make good decisions based on that. So I'm going to leave you with that thought. If you have any questions, I'm happy to take them.